Of Robokind, Richard Margolin.
Hey, uh, thanks for coming out on a awesome holiday like Prime Day. I'm Richard Margolin, the CTO and co-founder of Robokind. I'm going to talk to you about our new product and STEM curriculum that's called Robots for STEM. We create facially expressive robots and we use them in education. So basically, STEM is an acronym that stands for science, technology, engineering, and math. And one of the biggest problems we're having in education right now is figuring out how to actually educate kids in these areas. And within that, no one knows how to teach computer science. The reality is that we just don't have the teachers to do it, and we just are failing like pretty wildly. The stats on it are really simple. Over the last 2 decades, every STEM area, we've increased engagement in the number of classes kids are taking, except computer science. That's actually decreased in the last 2 decades. So it's not just we're doing worse than in other areas, we're doing worse than we were 2 decades ago. So we're really just failing in this area. And of course, it's really important to develop kids who actually have exposure to computer science, whether they become developers or coders or not. So what's the problem, right? It's hard. The way it's taught is really boring. And again, we just don't have the teachers to do it. High schools in the US, only 20% of them actually have a qualified teacher, and at the elementary school level, it's basically zero. And so that's kind of what we're addressing, and here's how. So traditional computer science is really boring. I hated it. I became a mechanical engineer, not a developer, because I hated every computer science course I ever took, because it looked like that. It was type a lot of stuff, misspell stuff, don't understand what's going on, try and hit compile, things go wrong, and then when you finally get it right, you're rewarded with that. Really, really boring. So, I mean, that's the reality of every class I ever took. It was terrible. What we are doing instead is we have our robots, and we have a virtual avatar of the robot, so that in a classroom, all right, that's not going to play. In a classroom, basically you can have one robot. There's one hiding in the corner over there. I'll go grab it in a second. And then we have a visual programming interface. So if the video played, here's what you would see. These little blocks over on the side, they do little things. So you grab a speak block and you drag it over under that start block, and you grab another block that's a motion block. And you do all of that, and you hit go, and the avatar smiles, he waves, and he says hi. And then you change out where it says avatar up there to robot, and you hit go, and the robot smiles at you, and he says hi. And that's the hello world exercise that kids need. Excuse me. So basically, like I said, we've got visual programming. That's not new, but what we're doing is we're making it more engaging by adding this virtual avatar, this full simulation of our robot, and the real robot in the classroom, so kids actually want to engage. So basically, you end up getting to do that instead of just typing forever and getting, not much. So like I said, it's less focus on syntax and spelling and all those things, and you get instant feedback. You hit go, you see something that's really engaging, and you get to play and explore. So it's individualized. We're really focused on individualized learning. Like I said, a teacher doesn't need to have any real computer science knowledge before they come in to teach this class. We provide tools, and the curriculum is simple, it's self-led, and it's project-oriented, so kids can go through it at their own pace. They can explore, they can do projects together and individually, they can have fun, and at the end of the day, because we have the avatar, they can go home and work on it there too, and they don't need to bring a robot home with them. So, it's all about engagement and excitement, because again, if you don't get kids actually involved, it really doesn't matter, what you've got. And so what we've found is that we're able to really engage kids. So that's a classroom we've been testing in. Excuse me. That's a classroom we've been testing in for the summer. Right now, we're testing in 8 schools for summer school. We've sold 40 schools this summer, and actually, that's wrong. We've sold 58 as of today. The deck was made last week. And so, all right. Yeah, so help us get into every school. So,
Awesome. Oh yeah, you promised to show them the doll.
So this is Jet. We're in production with this robot, a couple different characters you can see on screen. The one in the center is our first female character. She's still a prototype, but we'll have the first ones rolling off the production line in October. And this robot is not on, but he is facially expressive, and I can show you that later if anyone wants to hang around. So, questions?
Yes. So what is the cost per school?
Sure. So we do a kind of annual subscription model, but basically for a school to get started, it's about $10,000, and one robot plus the curriculum basically can service about between 3 and 5 classrooms, which usually will be 75 to 125 kids. So on a kind of per student cost, it's a really inexpensive. And then after the first year, once they already have the robot, it's only $3,500 a year. So, yeah.
So the system looks amazing, and especially targeted at the younger demographic. So you capture and engage them and inspire them to learn more. Do you have a bridge to go from there, something in between the syntactic hell that they're going to face later?
Yeah.
Like maybe custom templates or something like that.
So that's phase 2 for us, basically, with this curriculum. So the end of this curriculum, we start actually exposing the JavaScript that's being kind of created as they drag blocks around, and then the plan is a next curriculum that focuses on scripting, and then one that goes into object-oriented programming and things like that. And kind of long-term, I'd like kids to be able to start, as young as 2nd or 3rd grade, working with our robot and kind of learn to code all the way through and get to continue working with us.
From here. Say a classroom with 20 kids or 25 kids and
Yeah.
one robot, right?
Sure.
How does the queue system work, and how does one kid know that whatever they wrote is actually being simulated right now?
Sure. So the avatar that they actually get to run directly on their machine is what they primarily work with, and then there are kind of call-out days within projects and with the curriculum where they actually get to work with the robot directly. And so the teacher basically controls and gets to select what student gets access to the robot at any given time. Yeah.
So suppose a student is learning to code using this and they get really into it and they want to do it at home or in their free time, or maybe the teacher wants to assign homework. Is this like a web-based application or something that they can take home?
Yeah, so the visual programming environment is web-based, and we have a web-based option for the avatar. It'll run in browser, WebGL, and we're also releasing Chromebook, iOS, and native Windows and Mac apps for it as well. So.
Can it be like that hamster where every kid gets to take it home for like a little bit and pass it around?
Yeah, of course. Just make sure you feed the robot.
Couple of questions on the robot.
Yeah.
How long does this robot last? How is it maintained if it busts in the classroom? Because I can see a lot of 2nd graders getting disappointed when no one can get their robot. So reliability, dropping.
Yeah, so we've built these guys to basically survive about 3 years in a classroom. They're built to be around kids and handled by kids. You can be real rough with them; it's fine. He's built to be around children, and that was part of the intent. I know it's pretty, rough when you see someone just kind of beating on a robot like that. But all that nasty cracking you hear is actually safety built into the robot. And if they do break it, and sometimes that'll happen, our goal is basically to make sure a classroom's never more than 3 days without a robot. And we'll just get it swapped out, and we'll repair whatever we get back, and it'll go into a pool for replacements.
Part of their subscription fee is
Warranty, basically. Yeah, yeah.
How much does it cost you to produce a robot?
The robots right now are costing under $2,500 to produce. So
What if the robot needs a facelift? No, I'm just kidding. Can you go back to your other slide about? Sorry, I had to. It was actually credit goes to the guy behind me. He's funnier than me. Yeah, can you leave it on that slide and just remind us again what we can do to help? It was the what we need slide. Can you talk about that a little more?
Yeah, I mean, what we're looking for at this point is basically introductions to schools, school districts, anyone you know who can kind of help in that area, as well as corporate foundations who support education in STEM, who may be able to fund, first-year tests into school districts and give kids more access to this stuff.
Awesome.